Hi, my name's Ella, and this is my Experiment C presentation.
Starting with compound 1, after examining the IR and NMR, I identified the molecule as 4-ethanylaniline, which has this structure here. We can see the functional groups include a primary amine, a terminal alkyne, and an aromatic benzene ring. Here is the IR spectra for compound 1. At 2100, there's a small peak which provides a unique identifier for a terminal alkyne. Alkynes also produce a strong stretch at 3300, which is observed on the spectra here. With a combination of these two peaks, I felt confident an alkyne was present. Next, the combination of two strong peaks at 1600 and 1500 show the presence of an aromatic CC double bond. Lastly, a primary amine having two hydrogens bonded to the nitrogen atom will show two peaks between 3500 and 3300. On this spectra, we can see these peaks show up at about 3500 and 3400. Continuing on, here is the NMR spectra for compound 1. As expected, this molecule has 4 different chemical environments, producing 4 different signals. The presence of 2 signals between 6.5 and 8 ppm demonstrate 2 slightly different chemical environments on an aromatic ring. The signal at about 3.8 ppm lines up with a hydrogen bonded to a nitrogen atom on an aromatic ring, which is usually found between 3 to 5 ppm. Lastly, the signal at about 2.9 is likely to be a terminal alkyne. Terminal alkynes usually show a signal between 1.7 and 2.7. However, the aromatic ring causes deshielding, which is why this terminal alkyne is found slightly further downfield. I also used multiplicity to help me determine which signal was likely to be from which environment, just to make sure it aligns with the ppm values. The yellow group has no neighboring hydrogens, so it shows up as a singlet. Same with the primary amine, which is the green group here. The blue and purple group both have one neighboring hydrogen splitting the signal, so these are both doublets. Finally, I checked integration. All integrations match their respective groups, and I got a total of 7 hydrogens. This is consistent with compound 1. Moving on to compound 2. After examining the IR and NMR data, I identified the molecule as butan-1-amine, which has this structure shown here. We can see the functional group is a primary amine, and the rest is an alkane, meaning carbon-carbon single bonds only. Here is the IR spectra for compound 2. The most notable feature is a strong broad band between 3000 and 3500. The two peaks at 3364 and 3300 indicate this band isn't an alcohol or a carboxylic acid, but a primary amine, with one peak for each hydrogen. There's also a very recognizable sp3CH stretch. This represents the CH3 and all other CH2s in the alkane since they are all sp3 hybridized. A peak located at 1464.98 represents a CH2 bend, which usually appear at 1465. With all this information combined, I felt quite confident my molecule was an alkane with a primary amine. To further confirm, here is the NMR spectra for compound 2. This molecule has 5 different environments. However, it only shows 4 signals. This is likely due to the fact that 2 very similar signals combined into one. I knew it was likely to be 2 of the 3 CH2 groups, but to figure out which ones, I looked at deshielding. The green hydrogens are more deshielded due to their proximity to the amine, so they are found further downfield. This also matches up with the multiplicity. These hydrogens have 2 neighboring hydrogens splitting up the signal, so it produces a triplet. The purple hydrogens share a similar environment and are expected to be found further upfield than the green group was. With so many neighboring hydrogens, it makes sense to see a wide multiplet. The next signal is a singlet, which matches up with the primary amine. This group has no neighboring hydrogens, which is why it shows a singlet. This also lines up with how NH bonds show up between 0.5 and 4 ppm, with this signal sitting at 0.9 ppm. The last signal is at 0.7 ppm, which represents the CH3 group, which is usually show up between 0.7 and 1.3. This signal is also a triplet, which matches the 2 neighboring hydrogens. Lastly, I checked integration. All integrations matched up with their respective groups, and I got a total of 11 hydrogens, which is consistent with compound 2. Thank you for listening.